Now, question number 5. Differentiate in first part sin x with respect to cot x. Almost same thing which is actually calculated in or discussed in exercise 2.4. There we have actually algebraic function. Now we have two trigonometric functions. We have to differentiate one function with respect to another function. So the process is actually we just applied name or giving a name to both of these two functions. So giving a name to sin x, let y is equal to sin x, so this will become y, and then with respect to, this is actually will become differentiate y instead of sin x, we just giving a name to sin x to y. So differentiate y with respect to, and suppose let cot x is u, as let y is equal to sin of x and let u is equal to cot of x. Exactly the same thing which we have already used in our exercise 2.4. So now that will become differentiate y with respect to u. So when we apply differentiation of y with respect to u, we have to just calculate dy by du. So this is actually the final requirement of calculate dy by du. But y is the function of x, so from here we have to calculate dy by dx, and u is also the function of x, so from here we have to calculate du by dx, and then applying chain rule both of these two derivatives, then we calculate we will calculate dy by du actually. Now we start. Let y is equal to sin of x. Let y is equal to sin of x. Differentiate with respect to x, dy by dx, and derivative of sin x will become cos of x, and then let u is equal to cot of x or cotangent x. Differentiate with respect to x, du by dx will become as the derivative of cot as minus cosecant square x. Now we have two derivatives, du by dx and dy by dx, and by applying chain rule or joining these two derivatives, we will calculate actually dy by du. Now by using chain rule, dy by du is equal to dy by dx into dx by du. So just putting these two values, dy by dx is cos of x, and then dx by du, but we have here du by dx which is minus cosecant square x, and now when we change it to dx by du or taking reciprocal, that will become minus 1 over cosecant square x. So this is actually a value of dx by du which is minus 1 over cosecant square x. So finally we have dy by du is equal to cos of x, and this minus here, and 1 over cosecant square is actually sin square x. So that is actually a derivative sin x with respect to cos x will become minus cos x into sin square x. Almost the same thing again, you have to differentiate sin square x with respect to cos 4x. Solution, let y is equal to sin square x, just giving a name to both of these two functions, then y is equal to sin square x. Differentiate with respect to x, that will become dy by dx, and when we apply derivative on sin square x, first we use power rule which is 2 sin x containing power 2 minus 1, and then derivative will apply on sin of x. This is actually like 2 sin x containing power 2 minus 1 using power rule, and then derivative will apply on this inner function which is sin of x. So we have 2 sin x, and derivative of sin x will become cos of x. And our next part, u is equal to cos 4x. Let u is equal to cos 4x. Now differentiate with respect to x, du by dx, again using a power rule, 4 cos 4 minus 1 which is 3, and then derivative will apply on this inner function cos of x, which is differentiation of cos of x will become minus sin of x. So we have minus 4 sin x into cos cube x. Again we have two derivatives, dy by dx and du by dx. So joining these two derivatives by using chain rule, dy by du is equal to dy by dx into dx by du. Dy by dx we calculated here 2 sin x cos x, which is this one, and dx by du, just taking a reciprocal of this function, which is minus 1 over 4 sin x into cos cube x. By simplifying this one, 2 2s are 4. So in denominator we have 2. This sin x will be cancelled out to this sin x, and cos x, by dividing cos cube x, will become cos square x, and this is actually dy by du. Finally we have dy by du is equal to minus 1 by 2. This 1 over cos square actually secant square x. Now question 6. Given is if tangent y is into 1 plus tangent x is equal to 1 minus tangent x, then show that dy by dx is equal to minus 1. Solution: let tangent y into 1 plus tangent x is equal to 1 minus tangent x. We can write it tangent y 1 minus tangent x divided by 1 plus tangent x. As this 1 plus tangent x is multiplied to this tangent y, when we shift it to the right hand side, this will be divided by 1 minus tangent x. Now, just using a trigonometric result, here we have this tangent y will be as it is, and we can write tangent pi by 4 in place of 1, or instead of 1, as tangent pi by 4 is equal to 1. So we can write tan pi by 4 in place of 1, minus this tan x will be as it is, and 1 as it is. This tangent x will be as it is, and this tan pi by 4 will multiply to tan x, will remain tan x, as the formula of tan a minus b is equal to tan a minus tan b divided by 1 plus tan a into tan b. So just to complete this result, we just change or just modify to this expression in this style or in this way, so that this can be a formula of tan. So again you can see this tan x will be as it is. We just write tan pi by 4 instead of this one. So this is just a completion of this one. Tan of a minus tan of b, as this is tan of a minus tan of b, and in denominator we have 1. So this is 1 will be as it is, plus to complete this result we just have to write two tan functions. One is tan x, but there is no other tan functions, so we can write tan pi by 4 as there can be written as like 1. So just tan pi by 4 in place of this 1, which is actually the complete formula of like this one. So we have left hand side tan y, and on right hand side tan pi by 4 minus x. Just to merge this formula, comparing these left hand and right hand side, we have y is equal to pi by 4 minus x. Now this is a simplified form of this given expression, y is equal to pi by 4 minus x. Now differentiate with respect to x, dy by dx. This pi by 4 is the constant term, so derivative will become 0, and a derivative of minus x will be minus 1. So this is actually our required result, which we have to show that dy by dx is equal to minus 1. So again you can see we just change this function into this formula of tan x instead of applying differentiation from here. If we apply differentiation from this part, then that will be a very complicated expression, a very complicated situation to applying differentiation on this part. So rather to apply differentiation, we just use a technique to convert this trigonometric function in a generalized result of tan function. So we have just a very simplified form which is y is equal to pi by 4 minus x. To differentiate, we easily get our required form dy by dx is equal to minus 1. Question 7. If y is equal to square root 10x plus square root 10x plus square root 10x, and this is repeated up to infinite times, then prove that 2y minus 1 dy by dx is equal to secant square x. Solution: a given expression y is equal to this one 10x plus 10x plus 10x in square root form up to infinitely terms. So just squaring on both sides, this left hand side will be y square, and when we'll apply differentiation, when we apply actually squaring on both sides, then this square root, this first square root will be cancelled out by our square. We have this 10x plus this will be remain same 10x plus square root 10x plus square root 10x up to infinite terms. So you can see again, just to square on both hand sides, that will become y square, and on right hand side, when we apply squaring, or when we take a square of this part, then this square root will be cancelled out. We have just 10x plus this will be remain same 10x plus square root 10x plus square root 10x plus square root 10x up to infinite terms. So this y square will be as it is, this 10x plus this is actually the y. This is actually y which is given our question. Now we apply differentiation, differentiate with respect to x. Left hand side will be by using our power rule 2y and then 2 minus 1 dy by dx is equal to derivative of tan x is secant square x plus derivative of y will be dy by dx. As we have 2 dy by dx on both hand sides, left hand side and also on right hand side, so convert it to the or shift it to the left hand side. This dy by dx will become minus dy by dx by shifting to the left hand side, and on right hand side we have just secant square x. Now taking a common dy by dx as a common factor, so we have 2y minus 1 dy by dx is equal to secant square s, which is our required result. So hence proved.